Hey guys, it's Tom Cherryhams with the FujiNet project, and I wanted to make a video here showing why we need the end tools in certain cases. Well, to really do that, we need to take and demonstrate what the end tools are and why we actually need them. And for that, we'll actually start by going into apps. We'll go into Atari 8-bit here, and we're going to go into the DOS folder. Now, the DOS folder contains different disk operating systems for the Atari 8-bit with the N handler copied onto it, as well as all of the N tools and all of the F tools for controlling FujiNet. They're all here ready to be used. And I'm actually going to take and copy a copy of ATARI-DOS 2.0 because we're going to be putting MEM.SAV on it, and you can't do that on a public disk. So we'll take and do copy, and we'll copy that to our SD card here and put it right here. Sure. At which point we can then take and just use it. Okay. I'm going to demonstrate what happens. We'll mount it read right here. And I'm going to demonstrate what happens when you try to use the end device from inside ATARI-DOS 2.0. So once we're here, we take a look at what's on the drive here, and we see a whole bunch of utilities for doing things like controlling various FujiNet functions, such as listing disk slots, host slots, looking at directories and host slots, those things. Those are the F tools, and they control the FujiNet device itself. But there are also the N tools that take and change directory on an N device, copy files to and from an N device, delete files from an N device, do a directory, set login credentials, and so on. And we just actually added one called NLOAD, which can take and load binary files from an N device. But why do we need it? Well, if you look right here, you'll see that there's an auto-run sys right here, and it's 13 sectors long. And so it's roughly about a kilobyte and a half worth of code that gets loaded into the Atari, and then memload gets shifted upward. So the end device is actually loaded right now. I can take and demonstrate that actually. One moment, I will take and just boot back into, I'll take and insert a basic cartridge so we can show that it's actually working here. Attach cartridge. Give me a moment. Okay, I was off doing something else real quick. So there we go, bam. We insert our basic cartridge, come back in, recall that we're booting read right here. And once we're booted, we'll see that we're at the basic prompt here, and I can take and do network commands. I can change directory, for example, to my local file server. And I can take and write a little program. And I can save it to my network device that I've now changed the directory for. There it is. And I can also verify that it's now over here by going over to my TNFS folder. And we can see that our test basic file is right there. It saved it onto my file server directly. So we know that that works. But what happens when we load the disk utility package? We could, since NDEV is theoretically loaded, we could just do that, right? But it hangs. Why does it hang? Well, it hangs because the disk utility package has just written over the handler that's in memory. The disk utility package always loads at the same location in memory. It's not relocatable at all. It doesn't relocate itself. So the N handler is too big to fit in the space between memload and where the disk utility package loads. So the handler freezes up. You can't use it in ATARI-DOS 2.0. And there's an additional problem. If we take, I'm going to take and reset the system here real quick. Come back to the basic prompt here, and if I now do DOS and go back to basic, you might think, oh, well, I can use it here now, right? No, because what has happened, again, the disk utility package has overwritten the handler. So if I try to do that now, that handler is now gone. It has been completely obliterated from memory. So what you have to do if you want to use DOS 2, DOS 2.5 with the end device and you want to be able to preserve it in BASIC, you have to use the old MEM.SAV trick. So to do that, let's go ahead and get back to a clean system here first and foremost. We'll just take and do a DOS because I think we should be okay. And once this is loaded, since we've got our own local copy here, remember, we copied it to our SD card, and then we made a local copy, and we created and now we create a MEM.SAV. This file right here, its whole purpose in life, other than taking up 45 sectors on your disk, is to preserve the area that the disk utility package would normally take and obliterate when the DOS menu loads, and to restore it back whenever you either A, load a binary file, or B, go back to the cartridge. Now, since it's not being used right now, if we go back, it's just going to take and bounce back to basic here, and nothing's happening. But let's go ahead and reset the system. You'll see that it's right here. We can, of course, we can do our change directory. Everything's fine. And now we'll do DOS. But we'll notice something different when DOS loads. It will start writing to the disk. See? It deletes the file, then takes and writes it, and then goes to load DOS. Now, of course, the end device still doesn't work. We still can't use it because the disk utility package has clobbered over it, but at least now if we load a binary file, or if we go back to the basic prompt, it will load the end device back into the correct location in memory, preserving the memory. So now when I do this, it works again. So you see. So with that, now it comes back to the original question: why the end tools? So you see that you can't use the end device directly from inside the disk utility package, even though you can use it from inside other programs. So the way you get around this is that you write programs that directly use the FujiNet network device, and there's a whole stack of them. Again, for reference, we can change directories, we can copy things to and from, delete files, look at a network directory, set network login credentials, make directories, take a look at what our current directory is on that end device, rename files, remove directories, set translation modes, and finally, load binary files. Cool, huh? So, yeah. These tools do not require NDEV to be loaded. They can be copied onto any DOS disk and work from any DOS. They will automatically detect what DOS they're running under and whether or not to accept command line parameters or not. And if you're running on a DOS that doesn't support them, it asks you for them. So for example, if I take and run NCD, I can do this. I have this memorized. You've seen me type this a few times. So now I can take and then load in directory and take a look at all of the ACT files that are sitting in that in directory. And it works, and all of the tools work with N1, N2, N3, N4. So you can have these devices all pointing to different places. Let's look at all of the executable files that are in this particular FTP directory. There they are. So it's looking at those files directly in that FTP directory right here. So I can then take and go ahead and load one of them. It's fine. It has no issue with that. Like say, for example, I could then see, so now that I have NCD set up, I can, for example, if I wanted to take and copy something over, we can copy something over to a real disk drive here. We'll just take, and since I'm using this one because I have real disk drive emulation turned on with all the drive noises and stuff, so you can hear what this actually sounds like. So we'll make a new disk, sure. And yeah, you can mix and match Altera and FujiNet PC drives as long as they don't conflict. We'll take and make a nice file system here. Sure, go ahead, get that ready. And I will take and use NCOPY now. We'll start, and we have to specify the device spec here. We want to copy from in, and I want to copy, let's see, Kino to Kino. And there we go. It's taking that whole file and writing it out to disk. Okay, almost done here. It'll take and grab the file in 16K chunks and then bounce it over. All right, so there we go. Now that file is copied over, and so now if I actually take and go look at it, there it is. It's right there. It's been copied to my real floppy drive. Okay, so you can see you can bounce stuff over, and it can go the other direction too. So if I take and make a file, let's say if I take and I'm going to take an NCD over in my local file server, and I'm going to take and just make a quick file here and stuff it on the floppy drive just really quickly. And you'll notice right here, it says type Y if OK to use program area. This wipes out, if you're going to take and go back to basic or use something else, this will wipe out MEM.SAV here, so it will wipe out your handler. We don't need to do that, so I'm just going to say no, so that it preserves that. And now it's going to use the editor here to take and, I'm just going to type something. So there we go. That's now stored, ready to go. Now if I look at D2, we can see our little test text file right there, and I will take and use NCOPY to move that over. And yes, it goes back the other direction. Because I've set the prefix before to go point to my local file server, I can just do this. Done. And we'll see if we take a good look here at our TNFS. There's our test text file right there, ready to go. Now, I didn't apply any translation whatsoever, so it's being stored in a TASCII format here. This is being stored in a TASCII format. But if I had run intrans beforehand, I could say, well, I want this to be an ASCII, and it will take and transfer the line endings and everything so that I can bounce this back and forth between my machine, edit it on my PC, bounce it back to my Atari, and the whole process is pretty seamless. So with that, there's our NCOPY. But you can do more here too. So in addition, I'll take, and you'll see that there's a binary load file called Cyclod here. We'll take and use NLOAD to load it. All right, so we'll just take and say Cyclod. It's already pointing to the right place, so it just takes and loads it. So you can load binary files directly off of the network, nice and transparently. There we go, right? Looking good. We tried to do as good of a job as we possibly could. We got some memory conflicts here because we've got basic in. That's why that's happening. Oops. Let me just delete. We'll just detach that cartridge for now. It happens, but it works. Okay. Okay, so basics out here, and now I've shown you 2.0. Now this works on other DOSes too. So, for example, I can go into MYDOS. Standard MYDOS 4.53, nothing special here. Mounting it read-only, and this doesn't need MEM.SAV because it actually fits in the space. The handler will fit in the space underneath the disk utility package here, and it works. Great. So that basically means if we take a look at drive 1 here, we'll see all the usual suspects, and we'll see NDEV loaded as an auto run here. So I can basically do this now. I can take an NCD, One of the odd things about MYDOS, though, is it will completely reload the disk utility package here, so you have to wait for the DUP to load after you've used your tool. It's okay. But because the handler's still in memory with MYDOS and it's intact, I can do that. I can do an A to N, and it will give me back a directory that's been fully crunched and an 8.3 format here. And in point of fact, I can actually use the copy command and this works. Now this is the N handler doing this functionality here, not the N tools. But you can see that the functionality overlaps, and when you can use the N device, it's very nice and very transparent. And for the times that you can't, you still have the N tools. Okay, so now you've seen that we've taken and copied that over to our real drive over here. It works fine, but you're going to have a bit of a surprise when you try to load a binary file in this way. You'll see that we get back an error 146. And an error 146 means that that the handler tried to execute an unimplemented command. And the unimplemented command in this case is CIO function number 39, which is load a binary file. One of the fundamental differences between MYDOS and SpartaDOS versus DOS2, DOS XL, and whatnot is that the binary loader for the disk utility packages in each of those cases was relocated to the file management system, to the DOS sys, so to speak, so that you can use it from languages like BASIC and whatnot. But it does mean that because we're not using the D device to load these things, and that's what the FMS provides, the D device, we're using the N device, there's no command to take and do the binary load. Now we will add that command to the N device in the future, N device handler in the future. But for now, we do have a workaround. And that's where NLOAD comes into play. So we can basically just do what we did before, and it will do the right thing. So there we go. Now again, as I said before, the end device does support command lines. So that means essentially DOS XL, SpartaDOS, SpartaDOS X, that sort of thing. We can do binary loads that way as well. And for that, what I will actually do is I'll switch my system profile here to my loaded profile. Okay, let this come up. Yeah. I ripped out my VBXE on this profile. No big deal. Okay. So if you have an Ultimate 1MB with SpartaDOS X, you get these tools as well. So you're able to do things, even though you can't use the end device directly because it thinks that it's a floppy drive. We can still do send commands to take and change directory. We can do NDIR. We can get directories of these particular things. And if you provide it on the command prompt, it works fine. Okay, great. And you can do NCOPYs and whatnot here. We can see, for example, we have NLOAD here, and I'm going to take and copy NLOAD over so we can use it. So there we go. And I'm doing this because I haven't put it on the cartridge yet. And you'll find if I take and do NLOAD, I can take and still do this because I've NCD'd. You can see that it works just fine here too. So even under SpartaDOS X, you still have access to many of the different network functions until that will hold us over until we get a full-blown kernel driver to expose the network card. So there you go. I hope this has been at least somewhat instructive here to show why we need, what the end tools are and why we actually take and need them. And when I do say that they work anywhere, I literally do mean that they work anywhere. You saw previous screenshots. They work in DOS 3, it works in DOS 1, it works in DOS 2. We had to do some crazy workarounds to make sure that it works in DOS 2 because it does some things that none of the other DOSes do, and so on. But we've really tried to make it so that you can transparently use different FujiNet functions to take and bounce things around, access things on the network, and to do so in a method as transparent as possible. And we will continue to improve that in the future. So until next time, guys, have fun.